Welcome to Lesson 9.1, the very first lesson of Trimester 3 and Unit 9. Unit 9 is all about exponents. So, the first thing we're going to talk about is simplifying exponential expressions using some rules that you've learned over the years. So a lot of this lesson should be review. However, it's been a long time since we've used exponents, and that's kind of setting us up for the rest of the trimester. Okay, so your aim today is that I can use rules of exponents to simplify exponential expressions. So today we're talking about simplifying. We're not solving anything, we're just simplifying, making an expression smaller. There are many situations in science, engineering, and other fields where a process is governed by repeatedly multiplying or dividing the same quantity. That means if you have like 2 times 2 times 2 times 2. That happens often in these fields. Repeated multiplication and division is represented by exponents. We have worked with these already, but let's review some basics in the first exercise. So exercise 1. Exercise 1 is going to go through some rules of exponents. So each of the following problems involves basic exponent ideas. Answer each to review your previous knowledge. So each question is focusing on one idea. So letter A says represent 6 to the third as an extended product. So what does an exponent mean? Well, 6 to the third means as an extended product that I'm really doing 6 times 6 times 6. That's an extended product. I'm multiplying it out 6 times, right? This says do not evaluate, so I don't really care what 6 times 6 times 6 is. I just want to understand what that 3 means. It means that I'm multiplying 6 3 times. Letter B. If f of x equals 2x to the third plus 7, then f of negative 1 equals, okay, so I know function notation means I'm going to replace the x with the negative 1 and have 2 times negative 1 cubed plus 7. Be really careful when you use exponents and negatives that you put whatever you're plugging in parentheses, okay? This is going to equal 2 times negative 1 to the third power is negative 1 3 times. So I've got negative 1 times negative 1 times negative 1 plus 7. Negative 1 times negative 1 times negative 1 is negative 1. Order of operations now says I do 2 times negative 1 to get negative 2 plus 7, and negative 2 plus 7 is 5. I'm sorry, that was my phone. Okay? So the point of this exercise is to watch your signs, right? When you plug in a negative and you do it so many times, a negative times a negative is a positive, but then a positive times another negative would make that a negative. So you got to be really, really careful when you're multiplying with negative numbers, okay? Letter C. If x to the third power times x to the fifth power is written in the form of x to n, some number, what is the value of n? So write extended products if you don't remember the exponents rule. So the exponents rule we'll talk about after we try it ourselves. So this right here is saying, look, what happens when you multiply this out? What do you get for an exponent? Common Core does this a lot. They ask questions in this type of way. Instead of just saying what's x to the third times x to the fifth, they're asking you in a very different kind of way. But it's the same idea. So I'm going to say x to the third times x to the fifth equals, well, I've got, first of all, I have 3 x's, 1, 2, 3, and then I have 5 x's, 1, 2, 3, 4, 5. 5 x's, okay? So now I'm going to count up all my total x's. I've got 1, 2, 3, 4, 5, 6, 7, 8. So x to the third times x to the fifth is x to the 8. What is the rule here to remember? The rule here is what is 3 plus 5? 3 plus 5 equals 8. So your rule here is that when you multiply terms with exponents, you keep the base, but add the powers. That's the rule. And if you forget the rule, it's okay, because you can always do the extended, where you just extend it all out and add them all up. Okay? Letter D. Now we have another rule. If the expression 5x to the third raised to the second power is written in the form axb, what's the value of a plus b? I'm going to make a line here to say we're working on a different problem. So this is an interesting problem. This is a way of saying, look, if you simplify this right here, you're going to get a power here, and you're going to get a coefficient here. What happens when you add those two things together? That's what this question's asking. So the very first step we're going to have to do is simplify this, 5x to the third power, all raised to the second. When you raise an expression to a power, that power gets distributed to both things. But I think that let's show the extension instead. So this means that I'm going to take 5x to the third power twice. So I have 5x to the third power times 5x to the third power. I'm doing what's in parentheses twice. Then when I want to simplify this more, I'm going to say that I'm rearranging. It's 5 times 5 times x cubed times x cubed. 5 times 5 is 25, and we just talked about when you have multiplication, you add these two together. So this becomes 25x to the 6th power. That doesn't answer the question because what is this asking me for? It's asking me to add a plus b. Well, here's a. Okay, a is 25. And b is 6. So that means that I have to do a plus b. So what is a plus b? A plus b. Let me use a different color here. A plus b is going to be 25 plus 6. So my answer to this question is 31. Right? So this is a very common core type question. It's not just wanting you to simplify this expression, it's then wanting you to figure out what the two numbers are that you got, the a and the b, and add them together. So reading questions in this lesson is really important, and it will be really important in the mastery as well. Okay. Also, I know for a lot of you last trimester you struggled with some of the math. Please make notes in your notes where you're lost. So in class you can say, hey, look, at exercise 1, letter D, I don't understand this problem or what you did. Can you help me understand? And then we'll sit together in class and I'll go over it with you, right? So always keep that in mind, that this is not the end of the lesson, that you can always ask for help, okay? All right, letter E. If the length of a rectangle is 3 times 10 to the 5th meters, and its width is 2 times 10 to the 4th meters, what's its area in scientific notation? It's been a long time. Maybe. I don't know if you've done this in Ms. Van Buren's class or not, but let's take a look. We want length and width, and this question's asking for area. Well, I know that area equals length times width. So I'm going to say that my area is going to equal the length, which is 3 times 10 to the 5th, times the width, which is 2 times 10 to the 4th. So in the same way that I did letter D, I'm going to rearrange this. So I'm going to have, oh wait, I'm not going to change color. So I'm going to multiply the 3 times the 2, and I'm going to multiply the 10 to the 5th times the 10 to the 4th. 3 times 2 is 6, and 10 to the 5th times 10 to the 4th, remember you have to add that 5 plus 4, so this becomes 10 to the 9th. So this is my answer, right? Scientific notation is a easy way of writing a really big number, right? This number means it's 6 with 9 zeros. It's a very big number, and it's much easier to write it in scientific notation, okay? Letter F. The last review topic is a combination of multiplying and raising a power to a power. So this one says rewrite the product, 3x squared raised to the 2nd power times 2x to the 5th raised to the 3rd power as an equivalent expression in simplest form. So this wants you to just simplify these two things. So I'm going to do, first of all, I'm going to say, okay, well, 3x squared, I'm going to break off that first one. In fact, let me use a different color. So I'm going to first simplify this part. So 3x squared is really 3x squared times 3x squared. Then I have the second part, which is this 2x to the 5th raised to the 3rd power. So that's 2x to the fifth times 2x to the fifth times 2x to the fifth. All right. Now this top one becomes 3 times 3 times x squared times x squared. That gives me 9, because 3 times 3 is 9, x to the fourth, because I'm going to add those two exponents together. The blue one, then a little more space, is going to be 2 times 2 times 2 times x to the fifth times x to the fifth times x to the fifth. Now, like I said, you don't have to write this out every time. If you can see that 2 times 2 equals 8, you don't need to write this all out. If you can see that x to the fifth times x to the fifth is really 5 plus 5 plus 5, you can put down x to the 15th. You don't have, I'm just extending it all out so you can see. You can take the shortcuts if you know how to do that. Now I got to put both of them together. So I've got to put the 3x squared together and the 2x to the fifth. So it's going to be 9x to the fourth times 8x to the 15th. And now I just have to rewrite this. This is going to be 9 times 8 times x to the fourth times x to the 15th. So I'm going to get 72 x. What's 4 plus 15? 19. Okay. Notice how nice and neat my work is. Notice how I'm organized. If you have any questions, again, make a note and ask me in class or Ms. Samer or Ms. Vasquez. All right? So now let's go on to something a little bit that's less review. It might be review, but this is also kind of a tough concept. So let's pay really close attention to these next few sections. We'd also like to be able to write simpler equivalent expressions involving ratios or division problems involving exponents. This all comes down to your ability to unmultiply fractions, and we talked about this early in the year about this method. Now I'm going to teach you in this lesson the way they divide it into fractions here in this problem, and then in class I'm going to teach you a couple shortcuts. Okay, so let's take a look at exercise 2 with this division problem. So this problem says, consider the expression 2x to the 6th over 4x squared. Write this expression as the product of two fractions, one of which is equal to 1. So one way of simplifying something like this is to break up this expression into two fractions where one of them is equal to 1. Now, what that means is, here's a fraction that's, don't write this down, but just listen. This fraction, 2 divided by 2, that equals 1, right? Because it's the same thing on top. It cancels out to 1. If I write a squared bc over a squared bc, isn't this the same thing on top of the same thing? So this also still equals 1. We're going to use this idea of making a fraction equal to 1 to cancel out to help us simplify this problem right here. So what I'm going to do is I'm going to rewrite this decimal, sorry, not decimal, fraction. So 2x to the 6th over 4x squared. And I'm going to take out the lowest common thing they have in the numbers and the letters. So the 2 and the 4, I can take out a 2 on the top and I can take out a 2 on the bottom. Okay? For the letters, I can take out an x squared on the top and an x squared on the bottom. If I do this, the 2 is gone, right? And I'm left with x to the 4th. Because what's x squared times x to the 4th? It's x to the 6th. On the bottom, I took out a 2, so that means I have to have another 2 to get 2 times 2 to be 4. And the x squared is gone, right? It's canceled out. So I took it away. All right? So this is one way that we can simplify these fractions. Hold on, I'm sorry, my pen did a weird thing. So this is 2x squared, 2x squared. So this cancels out to 1, 1. So I'm left with 1 times x to the 4th over 2, which just simplifies to x to the 4th over 2. That is one way of solving this. The other way of solving, so that's what I did right here, where I simplified the expression. The other way of solving this, so this is method number 1. Method number 2 is where if I have 2x to the 6th over 4x to the 4th, I can break this up into 2 over 4 times x to the 6th over x squared. Now, one rule is when you divide terms with exponents, you subtract the powers. So just like if I multiply terms, I add. If I divide terms, I subtract. So I can simplify this 2 over 4 to 1/2, and I can say, okay, well, what is 6 minus 2? 6 minus 2 equals 4, so this just becomes x to the 4th. So I'm left with x to the 4th over 2. Either way, I get this x to the 4th over 2. Either way works fine. However, in lesson 2, you're going to see something weird happens with negatives. So I'd like you to do it both ways, to learn both ways, the fraction way in the purple and the shortcut where you can subtract when you divide. Okay, we're going to do some more practice with this in the next about, I don't know, 10 minutes of this lesson. Okay, well, maybe less than that. So let's take a look at the next page. So exercise 3, let's see if we can develop a sense on how to simplify these questions more quickly. Okay, so let's take this and do the fraction way. So notice here if I use the subtraction rule, so here let's use my subtraction rule again. This would be the same thing as saying, look, if I took 5 to the 3 out and 5 to the 3 out here, times, there's that's being taken out, what's left down here is nothing, I'm left with the 1, and what's left over here is 5 to the 4th. So my answer is 5 to the 4th. But the easier way, right, is to say, okay, well, what's 5 to the 7 minus 3? I can just subtract these two and also get 5 to the 4th. So 2 different ways to do these problems. I'm gonna show you both ways every time, and I'll write it in 2 different colors just so I can, you know, and if you have questions on this, please ask, because it's an interesting concept. So let's do the first way here. Here, I'm going to take out an x to the 4th over x to the 4th. Remember, it has to be the same thing on top and bottom. I'm left with a 1 here, and on the bottom I'm left with 6 other x's. This cancels out, and I'm left with 1 over x to the 6. Now that's interesting, because watch what happens when I do it the purple way. No, sorry, not the purple way, but the subtraction way. If I say this also is the same thing as x to the 4th minus 10, I end up getting x to the negative 6. You cannot have negative exponents. This is a general rule that you cannot have a negative exponent. And we'll talk more about negative exponents later. But to convert an exponent to positive, you just put it in the denominator. So I get the same thing before. So this, we're going to talk about more in lesson 2, but it's really important that you can't have negative exponents. You have to convert it into the denominator. And I think you've seen this before in 8th grade. So this shouldn't be terribly new. Okay, C, I'll do it the fraction way first in red. So I see that I can take out an x and an x on top. I can also take out 8 y's. What I'm left with on top are 3 more x's, and on bottom I'm left with 2 y's. So I get x cubed over y squared. That's the way to do it in red. The way to do it with subtracting is I can say, okay, I'm going to have x to the 4th minus 1, because remember there's a little invisible 1. If the letter doesn't have an exponent, it automatically has a 1. There's always invisible 1s, right? Times y to the 8 minus 10. When I simplify this, I get x to the 3rd, y to the negative 2. But remember, we can't have negative exponents, so the y over 2 would go on bottom and become positive. I get the same thing, but it happened that I feel like the red way was a little bit faster than the purple way. So it's really good to know how to do both ways, I think, depending on the problem. Okay? Alright. Exercise 4 are a little bit more complicated ones. If you want to try these on your own, please feel free. It's always good to pause and experiment and try on your own. So I'll do the red way and the purple way. This video might take a little bit longer just because I'm doing both ways. If you want to fast forward in the video and see the results, that's fine with me. So the first thing to do is we got to simplify this because we have to get rid of this power problem. So what I'm going to do is I'm going to say, okay, well, what is 3x squared to the 3rd power? So I'm going to write it out. I get 3x squared times 3x squared times 3x squared. This gives me 3 times... Oh, my pen is being silly. 3 times 3 times 3 times x squared times x squared. This gives me 27x to the 6th. The other way you can do this is distribute the exponent and multiply. So that's the shortcut here. There's lots of shortcuts with exponents, so you can use that shortcut. Now that I know that the numerator is 27x to the 6th, I'm going to rewrite my problem as 27x to the 6th over 9x to the 4th. Okay? Now I can do both ways. I'm going to do the way in red. So the way in red would be to take the common out. So I both have a 9 and a 9. And I have an x to the 4th and an x to the 4th that I can take out. This leaves me on top with a 3 because 3 times 9 is 27. And an x squared because 2 plus 4 is 6. On the bottom, the 9 is gone, and the x to the 4th is gone. So actually, this is like saying 3x squared over 1, which equals 3x squared. The way in purple, I can just subtract when I divide. So I can do 27 divided by 9 times x to the 6th minus 4. This will give me 3x squared. So it was a little bit faster, the purple method for this one. Okay. All right, letter B. Let's rewrite this here, and let's do the shortcut way to save some time. So I'm going to raise each of these. So I'm going to have 5 squared, which is 25. So 5 squared, so I'm going to rewrite instead of 5 squared and put 25. X squared squared is x to the 4th, and y third squared would be y to the 6th, because remember I'm multiplying here exponents. On the bottom, I'm going to do the same thing. I'm going to distribute that 2 to everything. 10 squared is 100. X squared is just x squared, and y squared is y squared. So I'll do the way in red first. So I'm going to take out a 25 from both. I'm going to take my pen for real. Sorry. Take out a 25 from both. I'm going to take out an x squared from both. And I'm going to take out a y squared from both. Remember, this is going to cancel out to 1. It's gone. And on top, I'm left with an x squared, and I'm left with a y to the 4th. On bottom, I'm left with 4, because what's 4 times 25? 100. And x squared and y squared are both gone, so my final answer is just x squared y4 over 4. And if my pen was not being silly, you could see this much better. That's a 4. Okay? Oh, yes, that's correct. Okay? All right, let's do it the purple way. We're almost done, guys. I know this is a bit of a long video. So the purple way would be to say, okay, what's 25 over 100 times x to the 4th minus 2 times y to the 6th minus 2. Well, 25 over 100 is 1/4, and x to the 4 minus 2 is x squared, and 6 minus 2 is y to the 4th. You can also rewrite this as x squared y to the 4th over 4. Either way, you get the same answer. Okay? Finally, the last exercise is an exercise in definition. So this diagram below shows how the expression gets simplified and what rules there are. This is memorizing from that very first unit we have about the associative properties, the definition properties. So very quickly, this is simplified to here by the definition of exponents. I can simplify 2x squared to 2x times 2x and extend it. Then, when I rearrange, I'm using the associative property. Remember, associative means that you're grouping. My pen is being frustrating. So this is the associative property. You're grouping here. Oh my gosh. I'm sorry, guys. I don't know what's wrong with my pen. Grouping. And finally, when you actually do your, and finally, the last step after this grouping is you're just multiplying your fractions, right? So this is just your multiplying fractions. Okay. I know this video ran like a few minutes longer than normal, but it's a really, really important skill. And sometimes Common Core words these questions in a really interesting way. So, you know, I want to give you guys as much exposure to that as possible. Now, when you get to your fluency, I know this year has been a lot of copying answer keys. I promise you the math this year is very difficult. So please, please, please attempt the fluency on your own and ask for help. I'm going to be much more serious about not helping on mastery. So get your fluency done. You got plenty of time. 1 lesson a day should be easy to do as long as the teacher is there to help you, okay? Good luck on your mastery, and I'll see you in class.